graph, of course, remember, all the info is the same for sine and cosine. Amplitude is your absolute value of A, absolute value of 3. Period, 2 pi over B. B is always the coefficient, regardless on which function we're on. It's always a coefficient in x. So 2 pi over 1. I'm just going to put 2 pi. Okay, increments. Period divided by 4, 2 pi divided by 4, pi over 2 when we reduce it. And, of course, we have a phase shift. Now, phase shift is the fancy phrase for the horizontal, the left and right shifts on the trig functions. How you know you have one, besides the fact there's a blank for it, okay, is you are adding or subtracting something to x. So you just take that expression, most of you can probably just do that in your head, set it to 0, and solve for x. So I'm going to subtract pi off. So I'm not going to be looking at 0, 0. I'm going to shift to the left negative pi. So picture our cosine curve here, shifted back here to negative pi to start with. And get ready for it. This is a good one. We also have a vertical shift. Our center line is going to change because that negative 3 at the back moves it down 3. So that's your new center line. So when I get ready to draw this, okay, work smarter, not harder. So I'm thinking about this graph. I don't want to quote unquote like skew the graph, but I'm trying to use the best space usage here that I can. So I'm thinking to myself already, it's going to shift left and shift down 3. So I'm not going to draw my x and y axes directly in the middle of my space over there, just to make it look a little nicer, because I'm already thinking it's going to shift to the left and shift down. So I'm going to kind of put my y-axis a little to the left, and I'm kind of going to put my x-axis up a little higher, and you'll see why in a minute. All right, let me get this drawn, Elliot, and then I'll answer your questions for you, okay? All right, first thing we're going to mark. So I didn't quote-unquote skew my graph. I'm just using my space, a little wise here. First thing I'm going to put on is my new center line, because from the new center line is you're going to count your amplitude. So I'm going to mark negative 3 first, and I'm just going to put a dashed line through it. So there's my downshift. Get it? Now, from our new center line, I'm going to count out the amplitude. Our amplitude is 3. So if I go up 3 units, we're going to go, our max height will be 0. I know you know it's 0. I'm just going to mark the 0 there, so dramatic emphasis, you know that's the highest I'm going to go. And I have to go down 3. So my lowest is going to be negative 6. So I'm going to draw between 0 and negative 6. That handles the down 3 shift. Now, pick up red here. We have the phase shift to negative pi. Okay, so we're going to back it off from 0, 0 to negative pi. So that's going to be where my first increment on the x-axis is going to be. Now, choices here. I don't care what you do, really. So always I label on the x-axis whatever you can. Personally, this is just me, since we have a center line shift, I like to put my increments on the center line because it just kind of draws my eye till that's where I'm going to be marking out the curve. If you want to leave them on the x-axis because it looks pretty, I mean, leave it up there, I don't care. But I'm going to put them down here on my new center line to draw my eye to this is the area I'm drawing. So it's a little bit of sometimes, oh God, that scared me. It's a little, scared me. All right, it's a little bit of a guessing game sometimes how far over to put your negative pi. Because as you start to increment, are you going to have a couple more in here? Is it going to get congested? You can always erase and change it. So I'm going to mark my negative pi over here. So we're going to add the pi over 2. And then, of course, like I said, I like to mark on the center line. Now add an increment, little fraction work. If you do negative pi plus a half pi, what's negative 1 plus a half? Okay, so I've got room. Now, if this was super congested, simple. I'd erase it and I'd move negative pi a little bit more over. Okay, keep adding your increments. What's negative half pi plus another half? 0. So I'm not gonna mark 0, but I'm gonna put a tick mark there so I know. Plus another half pi. And remember, it's 4 past the starting point for one full period. 1, 2, 3, 4. Half plus a half 1. Now remember, our period's 2 pi. like have a 2 pi on here. Doesn't mean we screwed up. Think about your range. From -1 to +1, you cover 2 pi. Okay. Now, our starting point. Let's draw it in red. So remember, cosine starts at A, we like to say, but we have a center line shift. So we're thinking, and we're at a phase shift. So this is like your new 0, 0. That's why I wrote it in a different color. So cosine's going to start 3 up from this point. So my starting point is -pi 0. So that's the tricky part when you have the shifting. So I'm at my max height, back to the center line, down 3 more, back to my center line, up 3 more. So there's my first period of cosine. Now, of course, I need the second period. I'm just going to keep going to the right because A, I have more room, and B, it's super easy for me to just keep adding a 1/2 pi. 1 plus a 1/2, 1 1/2 plus a 1/2, 2 plus a 1/2, 2 1/2 plus a 1/2. So from 1 pi to 3 pi, there's another 2 pi we've covered. And I'm just, because it's the second period, going to draw it in a different color. Back down to my center line, down 3, center line, up 3. So there's my second big hill. Got it. So I'm going to give you a second to finish drawing yours. Elliot, I haven't forgotten about you. So remember, left to -pi, down -3. That is like your new 0, 0 right here, my friends. That is the trickiest as it gets, is all the shifting. All right, Elliot, what do you got for me?
Well, the first thing I was going to say is if it's shifted left, then I would think that you would try and put the y-axis further to the right.
I mean, you could if you wanted to do your second period on the other side of it, for sure. It doesn't matter. I just did both to the right this time, just to show you to do both.
That was, okay.
Yep, just choices.
Also, when you're deciding the increments and you do the phase shift, does the phase shift always have to be, do you always have to orient the increments based on the phase shift?
Yes, mark the phase shift first and then do your increments from that point. Yep. Yep. All right, let's do a couple more. Now, this one, I took a little pity on you. You only have the phase shift. We don't have a center line shift. So not as bad, not as bad. Okay, amplitude, absolute value -2. Got it. Period. 2 pi over 4. Our B is 4. Over 4, pi over 2. This is going to be good. What's a 1/2 pi divided by 4? An 1/8. We got to scale by an 1/8 pi. I'm pretty excited about that if you can't tell. Okay, phase shift, of course. Again, as always, some of you can just do this in your head. We're going to take that expression with x, set it to 0, and solve it. So you'd subtract pi, of course, and then divide by 4. Now, no vertical shift. I should close this to save my battery. No vertical shift up and down, so we're still at 0. And we'll do our starting point when we get to it. So the nice thing is we don't have to worry about the up and down. So I like that. That's pretty legit. But we do just have to move it over a little bit. To me, a negative pi over 4, I mean, that's pretty tiny shift to the left. So that's not going to be too bad to do, I don't think. So I'm not getting too carried away about like making sure I have my axes and room on the graph. I'm just kind of centering it up here like normal. All right, let's mark our amplitude. It's nice and easy. Okay, first thing. This is going to be fun. First thing we're going to mark is the phase shift. Now, here's where you got to be good with fractions, of course. And it's always the question of, how far to the left should I put this -pi over 4? Because if I had an increment, is there going to be another one over there? I don't know. If it's messy, I'll erase it and move it. That's as wild as it gets, okay? So I'm going to put -pi over 4 here. Why did I write 8? How about 4? I said 4. I can't write in top. There we go. And now I'm going to do my increments. So I might have to move it. We're just going to have to see. So if I'm at negative pi over 4 to start with, and I'm adding an increment to that. Here's where you got to be good at fractions. Now, patterns, of course, will help us. Common denominators. 1/4 is the same as 2 over 8. Negative 2/8 plus 1/8. What's negative 2/8 plus 1/8? Negative. So I'm looking at my graph. I don't know if I love it. I think I'm going to move it. Because if I put negative at 8 in here, is it going to be really congested? And I did that on purpose to show you that sometimes, you know, just do a little erase action. A little erase action here. And I'm just going to move my phase shift a little bit more over. And we said we had negative pi over 8. That looks a little better. And that happens. Okay? Now keep incrementing. Now it's easy. Add another pi over 8 to that, and you're at 0. Add another pi over 8. Add another pi over 8. What's an eighth plus an eighth? Eighth plus an eighth. 1/4. 2/8. Remember, we need 1, 2, 3, 4 past it. Now, from negative 1/4 to positive 1/4, we do cover our full period. Okay, let's draw it in red, I guess. Now remember, sine, look at sine. Sine remembers the hill and the valley. But sine, we have our phase shift. I'm not going to start here at 0, 0. You're starting back here at negative pi over 4. So my starting point, I'm going to fill it in, negative pi over 4 to 0. Now, careful, careful. Check your lead coefficient. What's the lead coefficient? Negative. Valley and a hill. You've got the reflection. Valley and a hill. You've got to flip that guy. So down to 2, negative 2, center line, up to center line. There's the first period. Now, you pick. Do we want to do the second period to the right, or do we want to do it to the left? I see right. Probably a little easier to go right because you can just keep adding that eighth pi, hopefully pretty easily in your head versus subtracting. No judgment on our fraction. Well, maybe a little judgment on our fraction skills. So remember, that was 2/8 that we reduced. I already reduced it down for you. 2/8 plus another 1/8. 3/8 plus another 1/8. 4/8. I'm going to reduce it. 4/8 plus an 1/8. 5/8. 6/8. 3/4. And then I'm just going to repeat my valley and the hill. So again, when you're checking your answers, of course, if your graph looks a little different than mine, it's okay. We should all have, and you'll see, I try to kind of do them sometimes in color code, the same first period. You might have done your second one on the left. I don't care, that's totally fine. It doesn't matter to me. We voted on the right this one. All right, last one. Okay, amplitude. What's your amplitude?
1/2.
1/2, because I was mean to you. What did I do on this equation? I flipped it around, right? We should have the variable first. I just got fancy and did it, because sometimes they write them that way. Big whoop, okay? So just recognize, of course, technically, this should be our lead term. So our amplitude is 1/2. Which, okay, am I really going to draw it half the height of the period? I don't know, but we're going to try. Okay, period. 2 pi, this is fun, 2 pi over b. What's the coefficient? Well, they're using t this time. What's your coefficient on t? 4 pi. And remember, pi is just a number. 2 over 4, 1/2. Interesting. That's okay, we don't have to have pi on it. Pi is just a number. Okay, what is for our increments? Our period divided by 4. Half divided by 4. Phase shift. None. Are we adding or subtracting anything specifically to t? Sure, sure, okay. You can just cross it off, write none, I don't care. Center line. Y equals 1. We've got the up 1, the vertical shift. And we'll get to our starting point. Okay. So I'm looking, no phase shift, no left or right. So I'm thinking, you know, kind of in the middle. Yeah, I've got a center line at 1, but that doesn't freak me out because our height's only a half. It's going to be pretty tight. So I'm just going to kind of center it up here. So whenever you have a new center line, a vertical shift, always mark that first. So let's put our y equals 1 on. Now, this is going to be pretty tiny because your amplitude is a half. So if I go up a half, which this is, I feel like I need a note on here, not drawn to scale. So if I go up a half, I'm at 1.5. If I go down a half, I'm at a half. So I'm going to try to keep it drawn in between 1/2 and 1.5. Okay, that's going to be good. Now, no phase shift. We're incrementing by an 1/8. I do not care if you mark the increments on the x-axis or your center line to draw your eye to it. I'm going to do them on the center line. 1, 2, 3, 4, and counting by an 1/8. 1/8 plus an 1/8, 2/8. 3/8. 4/8. I just reduced them down. And of course we have cosine here. Let's draw it in red. Cosine starts at A. Now we're a half up from our new center line, so we're starting up here at 1.5. So I'm going to list my starting point. I'm at 0, 1.5. Back to my center line, down a half, center line, up a half. So we need our second full period. When you don't have a phase shift, I think it's easy just to go on the left and do the negatives. This makes it a little quicker. Got it. That's a 3/8, a sloppy 3/8 there. All right. And again, I don't care if you put the increments on your new center line or you keep them on the x-axis. Whatever makes you happy. That's what I'm all about. All right. Any questions on that? Looks like adult coloring in math class. Therapeutic. No? Maybe? No? Not feeling the therapy? A little bit?